All right, well, we're going to go ahead and move on to the next theorem on the page here, which again is going to talk about the idea of what domains are really possible for these power series, for these really long infinite polynomial things that are kind of like functions. So here's the idea. For any given power series, there are only ever going to be three possibilities that could happen with our domains. Here's the first possibility. The series could converge only when x is equal to x0. That's a possibility. That could be like it only converges at one special point. And notice it's the point that when I plug it in, it causes all these parentheses to just disappear. Now, we actually saw an example of something like this. If we were to kind of go back to look here at example number 2, we saw that the only value that we could use here was when x was a 0, which is what made a bunch of this stuff turn into 0. So that always seems to be an option that's on the table. If I was thinking about graphing my domain on a number line, we would be saying x0 is the only spot where I can go ahead and actually get the series to converge. The other option is that the series converges for all values of x. Well, okay, I mean, pictorially, that would look like, well, I guess this. x0, again, we're still imagining in the middle, but here I would grab all possible values. And if you look back on any of our previous examples, you would see that, well, we haven't seen any examples like that yet, but it is a possibility. And there will be some times where we will see that in the future. The final option is that the series converges, or essentially will have a domain for, this is kind of strange, absolute value of x minus x naught less than r, where r is some number that's greater than 0. Okay, we'll also put on here and diverges everywhere else. Okay, this is kind of a strange statement. Like, what the heck do we mean by this piece right here? Well, ultimately, what that communicates, if I was to solve that absolute value inequality, and I'll actually do that right down here, is that tells me that x minus x naught should be less than and also greater than these pieces, which ultimately then gives me that x's can be between x naught plus r and x naught minus r. Essentially, in a picture, the third possibility is that you can go up a little bit, down a little bit, and be convergent everywhere in between, but not outside. So this is kind of a really strange result. These are the only options for domains. You either get one point, you get all the points, or you get only points in one small connected interval of points. There's no possibility that I could have a domain that like can use values over here and all these values are good and then a couple values are bad but like values over here are good and then like some more values over there are good. Like that's not a possibility. That will never happen. It's only these three possibilities. The other thing to make note of here is that in this kind of third case up here, these endpoints could be included or may not be included. It just depends. And we saw that actually in the last example as well, where we had an interval from 2 to 4, but the 2 was included and the 4 was not. And that varies on every question. Okay, so if these are the only possibilities for domains, we're going to go ahead and kind of like give some different verbiage to what we refer to these things as. So here's what we'll say. We'll say that the interval of convergence, that's what we're defining here. You'll often see me abbreviated as IOC. The interval of convergence of a power series is the interval that consists of all x values for which the series converges. Essentially, the interval of convergence, another way to think about it would just be its domain. That's the domain of a power series. We just give it a different name. We call it interval of convergence. We also have another value to ultimately describe. What we'll see if we take a look back at all the pictures that we have up here is that what's always seems to be included in that convergent values is the x0, where the power series is centered. That value is included in red on all three of those pictures. And what we can then kind of see is that I can almost imagine that, like in the bottom picture, again, I'm stretching up and down by a value of r, some number. In the second picture, I can kind of imagine infinitely far in all directions. And in the first picture, I can imagine stretching 0 in both directions. So we're going to go ahead and give a name to that amount of stretch or amount of distance I can move from x0. We say this: the number r in case 3 above is called the radius of convergence, what I'll commonly abbreviate as ROC. It's the radius of convergence of the power series. In case 1, we would say that r is 0, because you can't stretch any distance to the left and to the right. And in case 2 up above, we would say that since you can stretch as far to the left or the right as you want, you get infinite. So again, that r is just meant to tell you how far away from x0 can you stretch. So there, r is a finite number. Up above here, r is infinite. And up here, well, you can't really stretch at all, so I automatically get r is 0. Okay. So when we take a look down here at examples 4 and 5, we'll see these are unbelievably simple because we already dealt with these. Here on example 4, this is related to the previous example of example number 2, and example number 5 is related back to example number 3. And we already answered these questions, but we can take a look at what we got. Consider the series from example 2. Can I identify the interval of convergence and the radius of convergence? Well, let's start with the interval of convergence. Okay? If I went back to example number 2 and I looked at the interval of x's that were able to be used, I would recognize the series only worked when x was 0. Well, that's not much of an interval. I mean, I guess we could write it as an interval that looks like this. It's an interval that goes from 0 to 0. Typically, we wouldn't even write it as that. More often than not, we would typically write it as just a single point with curly braces. But this is what we would refer to as a degenerate interval. That partially sounds like an insult. Okay, the radius of convergence here, though, would just be how far from x0 can I actually stretch? And here we saw, well, you can't stretch anything. You don't go left or right at all. All right. Now in example 5, we can see the same thing. If we wanted to identify the IOC and we wanted to identify the ROC, we could easily do that. We can easily tell where this power series is centered, just like we could in the last one. This power series is centered at 3. You can tell because there's a -3 in there on the x. And up above, we can tell that this is centered at 0 because there's an x not minusing anything. So here, I can easily see that if I was to go back and take a look at example number 3, that what we found is an interval that went from 2 to 4. So my interval of convergence here would be include the 2, don't include the 4. And I can tell here that 3 is smack dab at the center of that interval. And so the radius would be how far does it go to go from 3 all the way to the edge? Well, that's not hard to see. That's just the value of 1. Now, sometimes if you're really struggling to do that, or you're having difficulty remembering how you find the center, a really easy way to find the radius of the convergence would be to think about, like, if the radius is just half of the interval length, then can't I just immediately find the full length and chop it in half? So if you were really struggling to see that this was 1, you could also say that I could do 4 minus 2 for length of the interval and then chop it in half. That would get me the value of 1. There we go. Okay. This then kind of summarizes everything of our goal here for 6.2. We have these new kind of power series, polynomial function things, and we can kind of imagine that they could have a domain, values that could be plugged into them. If you take a look down here at example number 6, this is one that we would have left to be done in class during class time, so I'll leave that for you to go ahead and try on your own. Okay. If you got questions again on this section, please by all means let me know, shoot me an email, or see me in office hours.